teach you how to calculate the force. Now, after you have all the force, you just write it down on the members.
Lifu, you can use both of the boards now.
Okay. So now let me see. Chris should have this ready. So this one is negative. So that means this is compression. 22.5. This one is also 22.5. This is 0. This is negative 37.5. The green one is the force on the member. That one is just the length of the member. So it's not going to confuse you. Like this one is 37.5. This is 45. Okay. Now, wait, why Chris putting this?
You did unit load over there. Or was it at A?
We have this. We calculate the force for the wheel beam. Right now, we're gonna put. Because you want to find the deflection at point B. So what you're gonna do? You take this out, take the 30 out, and you just put 1 over here. So we use the same matrix, like the big matrix. We call it matrix 8. That is the big one. And right now, for the other side of this, let's call this matrix B. Since this force is gone, we're not going to put it, but we have a new point load putting at point B. So if you do that, you're going to have point B, 1, 2, 3, point B in the y direction. So it's 0, 0, 0, you should have. Because pointing down is negative, but when we do the matrix, negative numbers become positive number. So if we have something like pointing this way, 100, and pointing down 500, when you put in the matrix, you don't put negative. You don't put negative 100 or negative 500. Because pointing down, we assume pointing down is negative, pointing up is positive. This way is positive. This one is negative. In this case, this is negative 100. This one is negative 500. But when you put in the matrix, you switch sides. Negative become positive. Negative become positive. But if you have something like positive, like 500, when you put in the matrix, you're gonna get negative 500. You just switch the size. So in this case, we don't have the 500, nothing. We only have the 1 at point B. Because according to the matrix we just did, we're gonna have joint A, joint B. At joint B, the y direction, which is the 1, 2, 3, 4, the 4 column, we should have 1. So the rest just 0. 10 by 10, so yeah. So everything is 0. So we do the same thing. We take the big matrix, the one we get before, you just take this, put in the inverse, and then you times matrix B, the one we just did, times this. You're gonna get your new force of members. Instead of this, it's gonna change. So if you do that, do you know how to do that in calculator?
Matrices?
Yeah, matrices.
Yes. Don't worry about that.
Okay. So if you do that, you're gonna get new numbers. You're gonna get something like yeah, I didn't write down, but you should get something like this. Oh, fuck that. Just gonna write this down.
Here's another one.
Is that good or is it the same thing?
Here's this one works well.
Lee,
Hmm?
Lee,
Yeah.
Lee.
So you're gonna
That
have
one, try that one, it works.
no, it's fine. 0, 0, 0, 1, negative 1.25, and 0.75. You're gonna get that because instead of putting 30, we put 1 at the
B.
because we want to find deflection at point B. That's why we put 1 here. So if you do that, do the matrix, you're gonna get this new thing. And this one is not the length, it is the force of the members. So after that, we have the view beam and we have the unit load beam. So right now, we can I can use both ones.
Yeah.
Okay.
Am I feeling the
No,
way?
you know what? I'm just gonna use this one. Did I get a new one?
The black one, try the black one.
Let me see.
They're all bad.
Epic fail.
The black one on the right, you said this is good.
And a half.
All right.
Alright.
That one is called Midnight.
You have all your members, which is AB, AE something. Because you're gonna have AB, AE, same format as what we had before. BC, BE, CE, and ED. On this table, we're gonna have area. Area should be given, but in this case, they said area is a constant, so we're gonna have nothing. Just leave it like constant. And then the next column, you're gonna have the length of the member. So AB is 1.5. This one's 2.5. 1.5, 2, 2.5.
You didn't write all of that on truss. What's that? Okay, never mind.
And the next column, you're going to have the view.
You want me
I call it
to
F.
record or you want me to?
F means the view force on the member. F is force. So the view beam force, big F. So we're going to have negative 22.5, 37.5, 22.5, or negative 0, negative 27.5, and 45.
Isn't there force 2 on BE, or is that
What?
on BE? What's the 2? That's the length?
Come on, Mohammed, V. The next column, we're going to have small f. That means the force for the unit load beam. So for AB, we're going to have 0, 0, 0, 1, negative 1.25, and 0.75. You just see the members and just plug in numbers, so nothing else. And the last column is called F times small f times L divided by EA. If you have A, you just put in A. You have E, you put in E. But in this case, EA is constant, so nothing. So you're going to take this times this times this. That means this times this times this divided by EA. This times this, 0. You have 0. 0, you have 0. 0, 0. So this one you're going to have 117.19 EA. And this one is 50.63 EA. And for the total, the sum of this thing, it's just this plus this, because it's all 0. But if you have numbers, you just add them. So you're going to have 167.82 divided by EA. And this is your answer. And you should have some unit. In this case,
Inches.
No, it's not.
Deflection shouldn't be
Kilonewton meters.
Kilonewton
Kilonewton
Meters.
meters. This is
Kilonewton square meters.
square meters. No, displacement is cube divided by EA. Displacement is cube. So now we're done with the first method, the unit method. Now let's do the Carlos method.
Castellano.
No, I don't know how to pronounce that.
You call it Carlos?
And his first name or last name is Carlos. I'm just gonna call it Carlos.
I'm gonna think of El Presidente.
So this one,
Yep.
this is unit method. Now use the Carlos method. First thing, same thing. We have to find the wheel beam force. That's what we have. After that, you have the unit method. You just add on it. For the Carlos method, instead of putting 1, you have to put P. And the force, the one like the 30 we erased before, but for Carlos method, we put everything back on. Nothing delete. Everything is there, but you just put the P at the point that you're looking at. Because deflection, you put P. So this one is 30 because it's yeah. So we do the same thing. This is for unit method, but for Carlos method, you just use this and just add number on it. So for the 0, since we put P, so it's 0 times P plus the wheel beam numbers, which is negative 22.5. So plus, so it becomes minus 22.5. Same thing here, times P minus, this one's BC, yeah, minus 22.5. 1, before you have 0, so you have 1 times P plus 0. This one times P minus 37.5. This one 0. Same thing. You put P and you plus 37.5. Same thing here. P. You plus 45. Now we have all the numbers. So let's go back to this table. But this time we're gonna fix it. It's not gonna like that anymore. Member never gonna change. Area, same thing. If they give it to you, you use the real number. If they tell you A is constant, just use constant. Second column, the length of the members. Nothing changed. The length never changed. So same thing. But instead of F, you put N. I need more space. And nothing like this. And then for the N, before you have big F, now you have N. You just put in all the equation we just did. So for this one, you're gonna have, I'm gonna simplify it, but you should put 0 times P inside there. But in this case, you just put negative 22.5, because P times 0 is 0. So sending here, negative 2.2.5, and this one is this. No, it's not. No, this one's not.
It's 37.5.
37.5. And this one should be BC, negative 22.5. BE, what's that? P, and CE. So it's cis. Negative 125P minus 37.5. And for this one, you're gonna have 0.75p plus 45. And this columns, you're gonna put the derivative of n. So you're gonna take the derivative of this. Refer to p, I'm sorry, it's p. So the derivative of p. In this case, no p, so it's 0. No p, 0. No p, 0. P, derivative of p, just 1, so 1. This one, derivative, p become 1, so this one is cancelled, so you're going to have negative 1.25. This one, 0.75p, so we just take out the p, and you have this. For this one, it's called substitute set p is equal to 0. Because in this case, before we have nothing at point B, but we just add a p over here. Pretend here it had a p, but this p is actually 0. It's not there before, so it's nothing. So now you set p is equal to 0. But if the original question had this, like dirty kid or Newton, and the question asks you to find the deflection at this point, because you had to erase this and put the p here, you replace the dirty with p. So if in that case you want to find this one, you set p is equal to 30. You do that when you replace the p with something. In this case, you replace p with 0, so p is 0. So in this case, it's just the same thing. No, this should be the same. Like I told you, the reason why we have this, because I simplified it. The whole formula for n should be 0p times minus this. Now we substitute the p. Substitute p is equal to 0. So p is 0. So 0 times 0, 0. So all you have just this. So you can have this. In that case, you see this one, you just copy from that. Equation 2.5. P, put in 0, 0, because p is equal to 0. This one, p is 0, so it's negative 37.5. P is 0, so this one's gone, so it's 45. Last column is called, I'll just continue right here. It's called n over E8 times derivative of p times the L. So that means this, just n. Like I told you, E8 is a constant, so nothing changed. So you're going to use this times this, which is this, times L, which is this. So you use this times that. And 0 should be 0, because you have 0. You're going to have another 0, 0.
2p
Is L times p, because p is 0, right?
It's n times
L times.
that.
So it's gonna be 2p.
minus L. P minus 2.
No, because like I told you, p is 0.
Only in that column, no?
Oh, no, I'm sorry. It's p.
And
You had to use this times that. So p is 0. This one should be 0.
Here is more clear if you wanna.
Yeah, let me see that one.
Good, go.
Because like I told you, this one, p is 0. So this, just 0. Because p is 0. So this times that is also 0. And this one, you take this times this. Why still have this? Oh no, we use this. What the hell? That times that times that. So it's -1 times this times that.
The thing is that
Isn't it negative 1.25 minus L minus 2?
You just use this column.
the thing is that you don't need like,
You didn't worry about P, you did that already.
you don't need these columns because right here in and you're seeing that B is 0.
Right.
Just follow exactly what the formula says. You don't have to worry about P equals 0 and all that.
Yeah.
Okay. This 1, 2. It's not here. Yeah, this one should be 117.18 divided by EA. And this one should be 50.625 over EA. And the sum, you just add them up. It's going to be 167.82 kilonewton meter cube EA. That's it.
Lee, why?
Wait, I'll just stop it for
Pause.
pause. Yeah, this column is just this times that. This and this is the derivative and the length. And for this one, it's not your old one, but your new one. This one, let me call it this, new n, which is p equal to 0. You use this column for this one. The new one, the one you substitute the p 0 to b. So you're gonna use this times this times that. This one, and
Perfect, perfect.
that's it.
And that's the deflection?
That is your deflection. That's your deflection. If you they give you E and I, you take this divide by that, and your new unit should be deflection. Should be meter. And if they ask you for slope, your unit should be this radian. So we done with this. We use two methods. Yeah, we finished number 1.
Enjoy.